Okay, question 1, 1.1, solve for x. 1.1.1, you are given 3x squared plus 5x is equal to 0. Okay, so what is common? You have x in this term and x in this term. Okay, so you are going to factorize x outside of the bracket. Now, inside of the bracket, you are going to have 3x plus 5. You close your bracket equals 0. So you can see x times 3x, you have 3x squared. X times 5, you have 5x. Now let's carry on. X equals 0. Or x is equal to, when you take 5 to the right, you have negative 5. You divide by 3 on both sides so that you can have x. So x is equal to negative 5 over 3. Okay, always check your answers. Make sure the left side is equal to the right side. Okay, so let's move on. Now, question 1.1.2. The question says solve for x. You are given this and you are told you have to get your answers correct to 2 decimal places. Okay, so no need for you to factorize. You can use the quadratic formula. So this is what you are given. Okay, we are going to use the quadratic formula. This formula is given on the information sheet. Okay, so a is equal to 4, b is equal to 3, c is equal to negative 5. Okay, just as in alphabetical order. Okay, you have a, b, and c. So x is equal to, you are going to plug everything that you have. Okay, so this is equal to, use your calculator. Okay, so x is equal to negative 3 plus or minus. Okay, let's use plus and then we are going to use minus after. Okay, plus square root of 3 squared minus 4 times 4 times negative 5. Okay, over 2 times 4. Okay, this is equal to 0.80. Okay, correct to 2 decimal places. 0.80. Or x is equal to, now you are going to use minus. After you have used plus, you are going to use minus. Okay, let me change to minus. Okay, minus. You have negative 1.55. Okay, so always check your answers. Make sure the left side is equal to the right side. Okay, let's move on. Now, question 1.1.3. Okay, 1.1.3. You are given this. Okay, 4 marks. Solve for x. Okay, so this is a quadratic inequality. Okay, you are going to have x squared. So this is a quadratic inequality. This is how you can solve a quadratic inequality. Let's expand the bracket first. Okay, you have x squared. You multiply the two terms and then you multiply by 2. So x times negative 1, you have negative x, times 2, you have negative 2x. Okay, you multiply the two terms and then times 2. Now, negative 1 to the power of 2, you have plus 1. And then outside of the bracket, you have minus 9. greater than or equal to 0. You carry on, you have x squared minus 2x, 1 minus 9, this is minus 8, greater than or equal to 0. Now, you're going to factorize. You're going to have your bracket, okay? You have x times x, which will give you x squared. Now, you have minus 8. You need to have two terms. When you multiply the two terms, you are going to have minus 8. When you add the two terms, you are going to have minus 2. Okay, let's see. Let me show you. You have 8 is equal to 1 times 8. Okay, 8 is equal to 2 times 4. Okay, can you see? You can have 2 minus 4. Okay, 2 minus 4, you have minus 2. So, you can use 2 and 4. Okay, 2 and 4. And then, you are going to have minus 4 and plus 2. Okay, plus and minus 4. Okay, so that you can have the middle term. So, this is how you can solve. Okay, let me erase. We carry on. Now, you need your critical values. Okay, you need your critical values. This is how you go about solving for a quadratic inequality. You need your critical values. Okay, so your critical values, you're going to have x is equal to negative 2 or x is equal to 4. Okay, you solve for x. Okay, so x is equal to negative 2 or x is equal to 4. Okay, you solve for x. These are your critical values. Okay, you need your critical values when you are solving for a quadratic inequality. Okay, after you have your critical values, now you are going to use your critical values on a number line. Okay, you have your number line. Okay, so you have negative 2 and 4. So your critical values are going to divide the number line in 3 intervals. Okay, so you are going to use closed circles on negative 2 and on 4 because you have equal. Okay, you have equal. This is greater than or equal, greater than or equal. Okay, because you have equal, you're going to use closed circles on negative 2 and on 4. Okay, you are going to test your intervals. Okay, remember you have 3 intervals. You have this interval, the interval before negative 2, and you have the interval between negative 2 and 4. You have another interval, and after 4, you have another interval. So, you are going to test your 3 intervals. Okay? So, let me show you. You can do this without a calculator. Let me use a calculator so that you understand. Okay? We are going to test our intervals. Okay? So, let's start with this interval. The interval before negative 2. This interval. Let me show you. Before negative 2, you have this interval. Okay? So, you're going to use any number less than negative 2. So, you can use negative 3, negative 4, negative 5, okay, any number less than negative 2, okay. You can use even decimals, okay. you can use negative 3.5. Okay, any number less than negative 2. So you are going to plug in there, and then you are going to check if you have a positive or a negative answer. So let's try negative 6. Okay, negative 6 is before negative 2. Okay, negative 6 is less than negative 2. So let's plug negative 6 in there. Okay, negative 6 minus 1. You close your bracket to the power of 2, and then minus 9. You have a positive answer. Okay, you don't need to use a calculator. All you want is to find if the answer is going to be positive or negative. Okay, so we have a positive answer if we use any value before negative 2 or any value less than negative 2. So you have positive on this side. Now let's test this interval. Okay, let's test this interval. Okay, between negative 2 and 4. So you can use any number between negative 2 and 4. You can use negative 1 or 0 or 1 or 2 or 3 or 3.5 or 1.5. Okay, any number between negative 2 and 4. So let me use 2. Okay, I'm going to plug 2 wherever I have x. Okay, 2. This is a negative answer. So we have negative on this interval. Okay, let's test this interval. Okay, the interval after 4. So you can use 5, 6, 7, 8 all the way to infinity. Let's use 9. Okay, 9 is after 4. 9 is greater than 4. Okay, we can use 9 in place of x. You have a positive answer. Okay, so you have positive. Okay, so now you have greater than or equal to 0. Greater than 0 means positive. Okay, less than 0 means negative. So we are interested in greater than 0 in positive. So only this part and this part. So only this part all the way to negative infinity, and this part all the way to positive infinity. Remember, you have an equal sign. Negative 2 is included and 4 is included. This is why we use closed circles. So you have x less than or equal to negative 2. Okay, negative 2 is included. So x less than or equal to negative 2. You have all those values. Or x greater than or equal to 4. Greater than or equal to 4. Or you can solve this inequality using a parabola. You can see when you check this part, this is a parabola. Okay, this is a parabola. A parabola which is concave up, because the value of a, remember, the value of a in front of x squared is positive. So this is a parabola which is concave up. So you are going to have a parabola cutting the x-axis in -2 and 4. Okay? You have x is equal to -2, x is equal to 4. Okay? A parabola which is concave up, a smiling parabola, because the value of a is positive. Okay? The value of a is equal to 1. Okay? You have an invisible 1 in front of x squared. Okay? So a is a positive value. This is why you have a concave up parabola. Okay? Concave up parabola. A smiling parabola. So now you understand your parabola is going to cut the x-axis in -2 and 4. Okay, so now you are interested in greater than 0. Okay, greater than 0. So a graph is greater than 0 when the graph is above the x-axis. Okay, so you are interested in this only. Okay, only this, because you have greater than 0. So greater than 0 means positive. So above the x-axis, the graph is positive. Below the x-axis, the graph is negative. Okay, so we don't want this. We want greater than 0 above the x-axis. And we also have equal. So -2 and 4 are included. So you can use arrows to show that we are interested in all these x values. Okay, all these x values. The x values which are going to make the parabola positive. Not these ones. These ones, they are going to make the parabola negative. Okay, so you have x less than or equal to -2, or x greater than or equal to 4. Okay, so this is how you can solve this question. Let's move on. Okay, we're still on question 1.1. Now we are going to solve 1.1.4. Okay, 1.1.4. So you are given this. Okay, this question is 4 marks. Okay, so you have 5 to the power of 2x minus 5 to the power of x is equal to 0. There are many ways that you can use to solve this question. Okay, so let me use this way. You have 5 to the power of 2x. I'm going to take this to the right side. Okay, 5 to the power of 2x is equal to, now you have 5 to the power of x. Okay, the bases are the same. You have 5 and 5. When the bases are the same, you can equate your exponent. Okay, you can equate your exponent when the bases are the same. So you have 2x is equal to x. You carry on 2x minus x is equal to 0. 2x minus x, this is x, which is equal to 0. Okay, now question 1.1.5. You are given this. Okay, I can use cross multiplication. Okay, remember, this is over 1. I can use cross multiplication. So I have x times 1 this is equal to this times 1, you have this. Okay, cross multiplication. Let's carry on. Now you have to get rid of this. Okay, you have to get rid of the square root sign. You are going to raise everything to the power of 2 on both sides. So on this side you have x squared is equal to, you raise this to the power of 2, you are going to get rid of this. Now you have 20 minus x. So let's carry on. You have x squared, you bring this to the left, plus x, you bring 20 to the left, minus 20, equal to 0. Now you are going to factorize. So you have x squared, you are going to have x times x, negative 20. Negative 20 is, you have 20. 20 is 20 times 1. 20 is also 10 times 2. 20 is also 5 times 4. Okay, so you need to have the middle term, which is 1. Okay, you have 1x. You need to have the middle term, which is 1. Can you see? From 5 and 4, you can have 5 minus 4. Okay, 5 minus 4, you have 1. So I can use 5 and 4, and then minus there and plus there, because 5 minus 4, I'm going to have 1. Okay, so this is how you can factorize. Now from this, x is equal to 4, or x is equal to minus 5. Okay, always check your answers. Check that the left side is equal to the right side. Let's see. So you can use your calculator if you want. You have x over this. Let's use 4. So you are going to plug 4 wherever you have x. Okay. Can you see? This is equal to 1. So you have 1 on the left side and 1 on the right side. So this is a valid answer. Let's try negative 5. Negative 5, you have square root of 20 minus 5. Okay, minus 5. You are going to have plus 5. Okay, you have minus 1 on the left side and 1 on the right side. So this is not a valid answer. Okay, always make sure you check your answers. So we only have one solution. Okay, now question 1.2. Solve for x and y simultaneously. Okay, 5 marks. So we are going to call this, okay, equation number 1, and we are going to call this equation number 2. Okay, so now you can make x or y in equation number 1 or equation number 2. You can make x or y the subject of the formula, okay? You can use equation 1 or equation 2. So, I'm going to choose the simplest. The simplest is equation 1. So, from equation 1, y is equal to, okay, I'm going to make y the subject of the formula. So, y is equal to 9 minus x. Okay, so this becomes equation number 3. So, I'm going to take equation number 3 and plug into 2. Do not plug into 1 because equation number 3 is obtained from equation number 1. You cannot plug into 1. You have to plug into another equation, not into 1. 3 is obtained from 1. You cannot take 3 and plug into 1. This is not going to work. You have to plug into another equation. So 3 into 2. So this is 2. You have 2x squared minus y squared. So this is y. Okay, y squared equal to 7. Okay, in the place of y, you plug 9 minus x in the place of y. Okay, we carry on. You have 2x squared minus, let's expand what we have in the bracket. So 9 squared, 81. You multiply 9 times minus x and then times 2. 9 times minus x. This is minus 9x times 2. You are going to have minus 18x. Okay. And then minus x squared. You have plus x squared. You close your bracket. You bring 7 to the left. You have minus 7. This is equal to 0. Okay. You have 2x squared minus 81 plus 18x minus x squared. Okay. Because you have minus in front of the bracket. And then minus 7, which is equal to 0. Now, you have your like terms 2x squared minus x squared. This is x squared plus 18x. You have minus 81 minus 7. You have minus 88. This is equal to 0. Now, you are going to factorize. Okay. So, x squared. You are going to have x times x, which is x squared. Now, 88 is equal to 88 times 1 or 22 times 4. Okay, this is 88, or you can say 44 times 2. This is 88. So you need the middle term, 18. Can you see? 22 minus 4, you are going to have 18. So I'm going to use 4 and 22 because from 22 and 4 I can have 18. Okay, 22 minus 4. So I've got minus there and plus. Okay, 22 minus 4, I have 18. Okay, so you have x is equal to 4 or x is equal to minus 22. Okay, so you have x. You need y. Y is equal to, you are going to use x is equal to 4. You plug in there. So x is equal to 4. Y is equal to 9 minus 4, which is 5. Or y is equal to, you are going to use x is equal to negative 22. So you have y is equal to 9 minus 22. So 9 plus, okay, 9 plus 22. You have 31. Now question 1.3. 1.3, you are given p is equal to 1 minus a and t is equal to this. Okay, can you see the pattern? For t, you have 1 plus a times 1 plus a squared times 1 plus a to the power of 4, and you have something in between up until 1 plus a to the power of 512. Okay, now the question says determine the value of p times t in terms of a. Okay, 3 marks. So p times t, p is equal to this. Okay, p times t, this is t. Okay, this is p and this is t. Okay, can you see? This is p, this is p, and this is t. Okay, p and t. So this is equal to, can you see? You're going to have difference of two squares. You're going to have 1 times 1, 1, and then minus a times a. You have minus a squared. And for the middle term, you are going to have 0. So you have 1 times 1, which is 1, negative a times a, which is negative a squared. Okay, so you have this from this. Okay, let me show you. You have this from this. Okay, now can you see? This is going to be multiplied by this. Okay, can you see the similarity? The difference is only the minus and the plus. Okay, so this, when you carry on now from this, you are going to have this. Okay, 1 times 1, 1, negative a squared times a squared, you have negative a to the power of 4. The middle term is equal to 0 because of negative and plus. So you have this from this times this, the remaining. Okay, the remaining part, this. So times this. Okay, the remaining part. Can you see again? You have, can you see the similarity? The difference is only the minus and the plus. So this is going to be, you are going to have 1 minus a to the power of 8. So you have to notice you are going to get close to this. You are going to have 1 minus a to the power of 512 times 1 plus a to the power of 512. Okay? You are going to have this. You can observe the pattern. So this is equal to 1 times 1, it's 1, and then you have minus a to the power of 512 times a to the power of 512. You're going to have minus a to the power of this. Okay, you add your exponent. So this is the final answer. Okay. Now question 2.1, consider the geometric series. You are given a geometric series. So when it is about geometric series, you have to be thinking about these formulae. Okay. Now 2.1, question 2.1.1, does this series converge? Justify your answer. 2 marks. So for a geometric series, if the common ratio is between -1 and 1, greater than -1, less than 1, okay, then the series converges. So we have to find the common ratio. So to find the common ratio, always take next term, divide by the previous term. Okay, so I can take 2 over 4, which is 1 over 2, or I can take 1 over 2, which is 1 over 2, or I can take 1 over 2 divide by 1, which is 1 over 2. So to find the common ratio, you take any next term, divide by the previous term. So if I take T3 divide by T2, I'm going to have 1 over 2. This is 0.5. Okay, 0.5 is in between -1 and 1. I hope you know your number line. So you understand the common ratio is in between -1 and 1. Okay, so we are going to say yes, because the common ratio, which is 1 over 2, is in between -1 and 1. Okay, so with this condition, we are going to conclude that the series converges. Okay, now question 2.1.2, calculate the sum to infinity. You are going to use this formula. Okay, so you need A and R. A is the first term, R is the common ratio. Okay, so the sum to infinity is equal to A, which is the first term, 4 over 1 minus the common ratio, which is 1 over 2. This is equal to, you're going to have 8. Now, question 2.2, okay, you are given the following sigma notation. This is the sum of this, what you have in front of the sigma symbol, starting from P is equal to K all the way to P is equal to 10. This is equal to, you are given 29,520. Now, the question is calculate the value of K. So, let's expand what we are given. We are going to start with P is equal to K. Okay, so let me show you. If you start with P is equal to K, after you are going to plug K plus 1, and then you plug K plus 2, and then K plus 3, okay, and so on. Okay, so we are going to start with K. So let's get our expansion. Or let's get our series. You have 3 to the power of k minus 1, okay, plus after that you are going to plug k plus 1 in the place of p, okay, so 3 to the power of k plus 1 and then minus 1 plus, now you are going to plug k plus 2, okay, 3 to the power of k plus 2 in the place of p minus 1, okay, and you have terms in between, okay, you can carry on. Let's get our last term. So to get the last term, you are going to plug what you have above the sigma symbol. So 3 to the power of 10 minus 1. Okay, let's carry on. Now, this is equal to 3 to the power of k minus 1 plus 3 to the power of k. Okay, you have 1 minus 1, 0. You only have k. Okay, 3 to the power of k plus 3 to the power of k plus 1. Okay, this is 1. K plus 1 plus you have terms in between plus 3 to the power of 9. Okay, so now we are given the sum of this, which is equal to 29,520. Okay, we are going to use this formula. Okay, Sn, the sum to some numbers. Okay, do not use this. This is to find the sum to infinity. For the sum to infinity, you are going to have the infinity symbol above the sigma symbol. This is the infinity symbol. Let me show you. This is the infinity symbol. This, the infinity symbol. For sum to infinity, you are going to have the infinity symbol above the sigma symbol. So, in this question, we have this is equal to this. This is not the sum to infinity. Okay, so we need to use this formula. So, we need to find A. A is your first term. Okay, this is T1, this is T2, this is T3, and so on. So A is T1, which is equal to this. You also need to find the common ratio. The common ratio is usually this, okay? But you can find the common ratio. Always take the next term, divide by the previous term, okay? Always the next term, divide by the previous term. So, the common ratio is equal to, I can use this, 3 to the power of k over the previous term, which is 3 to the power of k minus 1. Okay, next term, divide by the previous term. This is equal to, you have division, the bases are the same. You are going to use the laws of exponent. So 3 to the power of, you are going to subtract your exponent. You have k minus k, okay, k minus k plus 1, okay. The negative is going to affect everything. So you have this exponent minus this exponent. So this is equal to, you have k minus k, 0. You only have 3 to the power of 1, which is 3. Now you need to find n, the number of terms for which we are calculating the sum for. So n is equal to, always you take what you have above the sigma symbol minus what you have below. You have k, okay? You have k plus 1, okay? What you have above minus what you have below plus 1. This is equal to, you have 10 plus 1, 11 minus k. Okay, let's find k. So Sn is given. You have Sn 29,520. This is equal to, you plug everything that you have into the formula. You can do cross multiplication. Remember, this is over 1. You can do cross multiplication. So you have 29,520 times 2, okay? Times 2, you're going to have this, okay? You cross multiply. Now, this is equal to 1 times this, okay? Cross multiplication. 1 times this, you're going to have this, okay? We carry on, you have this is equal to, you have multiplication, the bases are the same. You are going to use the laws of exponent. When the bases are the same, you are going to add your exponent. Okay, so you have k minus k, which is 0, and you have minus 1 plus 11. Okay, 11 minus 1, which is 10. You carry on. Now you have this times negative 1. You are going to have this. So you can take this to the left. You are going to have this, okay, to the left. This is equal to, on the right side, you have, let me show you. On the right side, you have 3 to the power of 10, and you bring this to the right, minus 59,040. You have 9. Okay. Can you see that? You can change 9 so that you have the same basis. You can write 9 as 3 to the power of 2. Okay? 3 to the power of 2. So that you have the same basis. So when the bases are the same, you can equate your exponent. So you have k minus 1 is equal to 2. Now you need to find k. So k is equal to 2 plus 1, which is equal to 3. Okay. Now question 3. Okay. Question 3, 3.1. Consider the quadratic number pattern 3, 7, 12, and so on. Okay. So 3.1, show that the general term of this number pattern is given by this. Okay, 3 marks. Okay, so you are given the following quadratic number pattern. Okay, so you have to think about this formula. Okay, because we are told this is a quadratic number pattern. Okay, quadratic number pattern. Okay, this is the formula, the general formula to find any term of a quadratic number pattern. Okay, quadratic number sequence. So we have to prove that Tn is equal to this. So let's find our first difference. You always take the next term minus the previous term. Okay, 7 minus 3, 4. And then 12 minus 7, 5. Okay, so this is the first difference. Okay, the first difference. Let's find the second difference. You have the next term minus the previous term. Okay, 5 minus 4, 1. So this is the second difference, which is constant. Now, we are going to use these numbers. Always use these numbers. Okay, so this one will always be equal to 2a. So you have 2a is equal to 1. You can solve for a. A is equal to 1 over 2 when you divide by 2 on both sides. Let's carry on. You're going to use this number. This number is always equal to 3a plus b. Okay, 3a plus b is equal to this number. Okay, so you have a, you plug a plus b, this is equal to 4. Okay, so 3 times 1 over 2, this is 1.5. Okay, 3 over 2, 1.5. To the right, you're going to have 4 minus 1.5. 4 minus 1.5, this is equal to 2.5, which is equal to 5 over 2. You have b. Now, you are going to use this number. This number is equal to a plus b plus c is equal to this number. You have a plus you have b plus c, which is equal to 3. Okay, you have 6 over 2. 6 over 2 is equal to 3. To the right, you have 3 minus 3. So c is equal to 0. You are going to plug a, b, and c. In the end, you have this. Question 3.1.2. What number must be added to Tn minus 1 so that Tn is equal to 13,527? Okay, so can you see this is Tn minus 1, which is the previous term, and Tn is the next term. So we have to find the position of this term, and then we are going to find the previous term, and then we can calculate how much you need to add to this so that you can find the next term. So we're still going to use this general formula. So we have to use this general term. Now let's find the position of this term. So Tn is equal to this. This is equal to, you have this. Now let's find n. N is the position of this term. Okay, let's find n. Okay, you can have this, and then you take this to the right, you have minus. Okay, now you only have 0 on the left. You can multiply by 2 throughout so that you can get rid of the 2 in the denominator. So by 2, you have n squared plus, by 2, you have 5n, okay, minus, by 2, you have this. This is equal to, by 2, you have 0, okay, you multiply by 2 throughout. Now, you are going to factorize, okay, so you have n squared, you are going to have n times n. You have to get two numbers. When you multiply the two numbers, you are going to have this number, and when you add the two numbers, you are going to get the middle term, which is 5n. You can use the quadratic formula to factorize. Do not stress, you can use the quadratic formula. Let me use my calculator with the quadratic formula. So you have to know the quadratic formula. The quadratic formula is given. You can see, you can find it on the information sheet. So you have minus b this is B, 5, right? You have A is equal to 1, B is equal to 5, C is equal to minus 27,054. Okay, so minus B plus or minus, let's use plus first, and then we are going to use minus after. Okay, square root of B squared, so B squared minus 4 times A is 1, times C is negative 27,054 over 2A is 1, okay, is 1. You have an invisible 1 in front of n squared. So this is equal to 162, okay. When you bring it back inside the bracket, you have negative, okay. Remember, when you are going to solve, you are going to have n is equal to 162, okay. Let's find another root. Now you are going to use minus there. You have this, you are going to have plus 167. When you solve, you are going to have minus 167. Okay, so n is equal to this, or n is equal to this. Okay, so n cannot be negative. We need this. Okay, so you have t 162 is equal to this term. Okay, so t 162 is equal to this. Now the previous term, okay, t n minus 1, which is t 161, this is equal to, you are going to use the general term, okay, the general formula. So 1 over 2 n is 161 squared plus 5 over 2 times n is equal to 161. This is equal to, you can use your calculator if you want. Okay, you have this. Okay, so now what number must be added to this so that you have this? You are going to take this minus this. You have 164. Now 3.2, given an arithmetic sequence with t1 is equal to 8 and t2 equals 11. 3.2.1, calculate the value of n if tn is equal to 41. 3 marks. This question is about arithmetic sequence, so you have to be thinking about this formulae. Now 3.2 and 3.2.1, calculate the value of n if tn is equal to 41. So you have to use this formula. A is equal to T1. Okay, A is equal to T1. You need D. D is the common difference. Always take the next term minus the previous term. Okay, so you have T2 and T1. You can use this. Okay, so you have 11 minus 8. Okay, next minus previous. So this is equal to 3. Now let's find n. So Tn is equal to 41 equals A is equal to 8 plus in bracket n minus 1, you close your bracket, times d, which is 3, you have 41 is equal to 8. Now you have 3 times n, okay, plus 3n, 3 times negative 1 minus 3. Okay, you carry on. Now take 41 to the right. You only have 0 on the left side. This is equal to 3n. You have 8 minus 3, which is 5. 5, okay, 5 minus 41. This is minus 36. You're going to have 3n is equal to 36. Okay. N is equal to 12. So T12 is equal to 41. Okay. Now question 3.2.2. A new arithmetic sequence P. Okay. A new arithmetic sequence P is formed using the term position and the term value of the given arithmetic sequence. Okay. They are using the given arithmetic sequence to form a new arithmetic sequence which is called P. For the new sequence, P8 is equal to 1, P11 is equal to 2, and so forth. Now, question A. Write down the value of P41. 1 mark. Can you see P8 is equal to 1? Okay, P8 is equal to 1 and P11 is equal to 2. Can you see? They are using this. Okay, they are using the given arithmetic sequence. P8 is equal to 1. P11 is equal to 2. Now, P41 is equal to, can you see? You have T12. T12 is equal to 41. Now, P41 is equal to 12. Now, question B. Calculate the value of the first term of the new arithmetic sequence. 4 marks. Okay, you have to calculate P1. Okay, first term, P1. So, you have P8, P11, and P41. Now, find P1. We are going to solve this question simultaneously. Okay, so let's use what we are given. So P8 is equal to, remember, this is an arithmetic sequence. You are going to use this. Instead of T, you are going to use P. Okay, Pn is equal to A plus, in bracket, n minus 1. You close your bracket, times D. Okay, you have A. Okay, A is your first term, which we have to calculate. So, we are going to solve this question simultaneously. So, A plus, in bracket, n is equal to 8. Okay, P8, n is equal to 8 minus 1. You close your bracket. We don't have D. Okay, we don't have D. This is equal to P8 is equal to 1. Okay, this is equal to 1. Can you see? So you have P8 is equal to A plus, you have 7. Okay, 7D, which is equal to 1. Okay, so we are going to call this our first equation. Now, let's use P11. P11 is equal to A plus, in bracket, n is equal to 11. Okay, 11 minus 1. You close your bracket, times D. This is equal to 2. Okay. So P11 is equal to A plus 10. Okay. 11 minus 1. 10. 10 D, which is equal to 2. So this is going to be our second equation. Now we can find D, and then after finding D, we can find A. Okay, so from equation 1 or 2, you can make D or A the subject of the formula. Okay, let me use equation 1. So from equation 1, A is equal to, okay, A is equal to 1 minus, okay, minus 7D. This becomes our third equation. Now you are going to take 3 into 2. Okay, not into 1. 3 is obtained from 1. You cannot take it and plug into 1. It's not going to work. You have to plug into a different equation. So this is equation 2. You have A plus 10D is equal to 2. So this is A is equal to this, okay, plus 10D, which is equal to 2. Now you are going to have 10D minus 7D, which is 3D. This is equal to 2 minus 1, which is 1. So D is equal to 1 over 3. Now A is equal to 1 minus 7D. D is equal to 1 over 3. This is equal to, you're going to have minus 4 over 3. Now question 4. Okay, question 4. Given g of x is equal to 1 over x minus 1 plus 2, 4.1. Write down the equations of the asymptote of g, 2 marks. This is the equation of a hyperbola. A hyperbola has got 2 equations of the asymptote. Okay, you have a horizontal asymptote and a vertical asymptote. So to find the vertical asymptote, you are going to take what you have in the denominator. Okay, you are going to take what you have in the denominator. Okay, you equate it to 0, and then you solve for x. X is equal to 1. So always take what you have in the denominator, equate it to 0, and solve for x. Okay, because division by 0 is undefined. So when you have division by 0, you are going to have a vertical asymptote for a hyperbola. Okay, and a hyperbola has got a horizontal asymptote. So the horizontal asymptote, you have y is equal to, you are going to take what you have there. Okay, so y is equal to 2, whatever you have there, whether negative or positive, y is equal to what you have there. This is your horizontal asymptote. Let's carry on. Now, question 4.2. Draw a graph of G. Draw the hyperbola, indicating any intercepts with the axis and asymptote, 4 marks. So, for you to draw the graph of a hyperbola, you need to know your vertical asymptote and your horizontal asymptote. So we have the vertical and horizontal asymptote. you also need the intercept with the x's. So to find the x-intercept, let y equal to 0. So this is y. G of x is y. So you let y equal to 0 so that you can find the x-intercept. So this is y. You let it equal to 0. So you have this equal to 0. Okay? You need x. You are going to have this equal to minus 2. You can do cross multiplication. Okay? So this is over 1. You can do cross multiplication. So you have negative 2 times this. Okay, cross multiplication. Negative 2 times this. This is equal to 1 times 1, which is 1. You have negative 2x. Okay, plus 2. Okay, plus 2, which is equal to 1. You have negative 2x is equal to negative 1. Okay, 1 minus 2. X is equal to, you are going to divide by negative 2 on both sides. Now, to find the y-intercept, let x equal to 0. This is y. Y is equal to, you have 1 over 0 minus 1 plus 2. So y is equal to 1 over negative 1. You have negative 1 plus 2. So 2 minus 1, which is 1. Now you can draw your graph. This is the x-axis. This is the y-axis. You have your vertical asymptote at x is equal to 1. Okay, x is equal to 1. On the x-axis, x is equal to 1. Okay, and you have your horizontal asymptote at y is equal to 2. On the y-axis, y is equal to 2. Okay, now you have your x-intercept at x is equal to 0.5 on the x-axis, 0.5. Okay, between 0 and 1. Okay, 0.5. And you have the y-intercept at 1. Okay, y-intercept at 1 there. So can you see your graph will be like this? Okay, like this. Can you see? This is the graph of G. Okay, the graph of G. Now question 4.3. Determine the values of x where g of x is greater than 0. 2 marks. Okay, for g of x to be greater than 0, you have the graph is above the x-axis. The graph is positive. The graph is above the x-axis. Okay, so you are interested in this part and in this part. Okay, above the x-axis. You are interested in this part, not this part. This is negative less than 0. You are interested in greater than 0. Okay, above the x-axis. Okay, above the x-axis, not below. At the x-intercept, the graph is equal to 0. Okay, at 1 over 2, the graph is equal to 0. You don't have equal to 0. You only have greater than 0. So you have x less than 1 over 2. You have the graph is greater than 0 above the x-axis, okay, positive, this is positive, or x, you have this greater than 1, greater than 1, you have the graph is above the x-axis. Now, question 4.4, determine the equation of the axis of symmetry of G which has a negative gradient. So, the axis of symmetry is in the form y is equal to mx plus c, because it is a line. This is a line. So, the gradient is equal to -1, okay? -1. If you ask to find the equation of the axis of symmetry of G which has got a positive gradient, you are going to have 1, a positive 1. So, you have m, you need c. So, you have to know that the axis of symmetry is going to pass at this point, okay? The coordinates of this point are 1 and 2. You can see from the equation the coordinates are 1, okay, 1 and 2. Okay, so y is equal to -1 times x. You have -x plus c. Now, to find c, the axis of symmetry passes through the point, this point 1 and 2. So, you can use this point to find c. So, this is x, this is y. Okay, the first coordinate is always x, the second coordinate is always y. So, this is y, which is 2 equal to minus x, x is 1 plus c. So, c is equal to, okay, c is equal to 2 plus 1, which is 3. And now you have the equation is y is equal to minus x plus 3, okay? Now, question 5. In the diagram, the graphs of f of x equals log of x base a and g are drawn. Graph G, okay, graph G is the reflection of f in the line y equals x. Graph f, okay, graph f passes through the point P, this point. Q is the x-intercept of f. Okay, Q is the x-intercept of f, and R is the y-intercept of G. Okay, R is the y-intercept of G. Now, 5.1, write down the coordinates of P dash, the image of P on G, 2 marks. So, you have P on the graph of f. P dash is the image of P on the graph G. So, when you read, let me show you. When you read this part, graph G is the reflection of f in the line y equals x. So, y equals x. This tells me the two graphs are inverses of each other because the reflection is happening in the line y is equal to x. So, P dash is on the graph of G. To find the inverse of a point, you are going to swap your x and y coordinates. So, P dash, you are going to have 2 and 4. Okay? So your x coordinate is 2, your y coordinate is 4. 5.2 show that a is equal to 2. 2 marks. You have a in the equation of the graph of f. We are given f of x is equal to this. You have x is 4, y is 2. The first coordinate is always x. The second coordinate is always y. So this is y. F of x is y equals log of 4 base a. Now you have a to the power of 2. Whatever you have on the other side is your exponent. This is your base. A is written as the base. You can see this is the base. So you have a to the power of 2. Whatever you have on the other side of the equal sign is your exponent. So this is equal to 4. So you have a to the power of 2 is equal to, you can change 4 and write 2 to the power of 2. So when your exponents are equal, now you can equate your bases. So you have a is equal to 2. Now question 5.3, write down the equation of g in the form y is equal to, okay, 1 mark. G is the inverse of f. So we are going to use the equation of f to find the equation of g. So you are given f of x is equal to this. Okay, remember a is equal to 2. So this is f of x. Let's change f of x to y. So this is y. Okay, now let's find g, which is the inverse of f. To find g, which is the inverse of f, you are going to swap your x and y. So you are going to have x is equal to log of y base 2. Okay, so you have your base is 2. Whatever you have on the other side is your exponent. So you have y is equal to 2 to the power of x. Okay, y is equal to 2 to the power of x. Question 5.4, t is a point on f, on the graph of f, in the first quadrant, where tr is parallel to the x-axis. So t is a point on the graph of f in the first quadrant. So the first quadrant is always formed by the positive x-axis and the positive y-axis. This is the first quadrant. This is the first quadrant. This area always formed by the positive x-axis and the positive y-axis. You have your first quadrant by the axis on the right and the axis at the top. Okay, let me erase. So we have t in the first quadrant on the graph of f, and tr is parallel to the x-axis. So you have this. This is tr. So the question says calculate the area of triangle RTP dash. Okay, RTP dash. Let's find the coordinate of R first, and then we are going to find the coordinate of T. R is the y-intercept of the graph of G. You have the equation of the graph of G in the form y is equal to. So R is the y-intercept of the graph of G. Okay, so we have to find the y-intercept of the graph of G. To find the y-intercept, you let x equal to 0. We are going to use this graph because R is on this graph. R is the y-intercept. So this is the equation of the graph of G in the form y is equal to. So let x equal to 0 to find y. This is equal to 1. Now you have the coordinates of R. Okay. Remember, at the y-intercept, x is equal to 0. Okay. Now, the coordinate of t. Can you see R and t? They have the same y coordinate because this is a horizontal line. We need the x coordinate there. Okay, so find the coordinate of t. We have the y coordinate, we need the x coordinate. So t is a point on the graph of f. Okay, t is a point on the graph of f. We are going to use the equation of the graph of f. This is the equation. So we have y, f of x is y is equal to 1. We need x. This is equal to log of x base 2. X is equal to 2 to the power of 1. So you have 2. Now you have the x coordinate. Okay, the coordinate of t. Now can you see t and p dash, they have the same x coordinate. So you understand p dash is there. Okay, you have a horizontal line and a vertical line. So you have a right angle there because you have a vertical line and a horizontal line. Okay, now you have your triangle. Now let's find the area. The area is equal to 1 over 2 times the base, okay, RT times the perpendicular height P dash T. This is equal to 1 over 2 times RT. RT is equal to 2 from 0 to 2 times P dash T. P dash T, okay, from 4 to 1 you have 3. Okay, 4 minus 1, 3. So this is equal to 6 times 1 over 2, which is 3 unit squared. Now question 6.1, write down the range of f. 1 mark. 6.1, the range of f. The range of a graph is always found on the y-axis. You start from the bottom, you go to the top. Okay, from the bottom to the top. You are given the coordinate of the turning point. So this graph starts at -4. Okay, at -4. The range is always obtained on the y-axis, -4 all the way to positive infinity. -4 is included. So the range, you are going to write y greater than or equal to -4, or you can write the range in interval notation. You have y element of -4 all the way to infinity, all the way to infinity, from -4 all the way to infinity. You have a square bracket because -4 is included. So you have to use a square bracket because -4 is included. Okay, all the way to infinity. Infinity is not a number. You have to use a round bracket. Now 6.2, calculate the coordinates of D and E, 3 marks. So D and E are the x-intercept of f. You are given the equation of the graph of f. To find the x-intercept, you let y equal to 0. This is y. You let y equal to 0. Now you are going to factorize. Okay, x squared, you are going to have x times x. Now you have 3. Okay, 3, -3. So 3 is 1 times 3. Okay, so from 1 minus 3, you have -2. Okay, so you can use 1 and 3. So you have plus and minus. X is equal to -1, or x is equal to 3. For D, you have -1, 0, and E, you have 3, 0. Now question 6.3, determine the equation of G. G is a line, so G is in the form y is equal to mx plus c. So find C, the y-intercept of G. Okay, using the equation of f, you can find C. Okay, the equation of f can be used to find C. This is C, the y-intercept. This is C in the equation G, which is the y-intercept. Okay, so f and G, they have the same y-intercept. Okay, so the equation of f can be used. F of x is equal to this. So from this, C is equal to -3. So find M. You need any 2 points on the graph of G to find M. Any 2 points. You have E. Okay, you have E, and you also have P. Okay, you have P. Remember, at the y-intercept, x is equal to 0. Okay, so you have 2 points that you can use to find M. So M is equal to, you have change in the y over the change in the x. You can start from P going to E, or you can start from E going to P. Okay, I'm going to start from P going to E. So change in the y. This is y, the second coordinate. -3 minus, okay, -3 minus 0 over 0 minus 3. So you have -3 over -3, which is 1. Okay, and now you have the equation of G. 1 times x, which is x. C is equal to negative 3. Okay, you have the equation of G, a line. Now, 6.4, write down the values of x for which f of x minus g of x is greater than 0. 2 marks. Okay, you are given f of x minus g of x greater than 0. You have f of x greater than, you have minus g of x to the right. Now you have positive g of x. So now you have f of x greater than g of x. So f of x is greater than g of x wherever you have f above g of x. So let me show you. F is above g on this part and on this part. You have f above g. This is g. On this part, f is below g. Okay, so at the point of intersection, f is equal to g. You don't have equal, you only have f greater than g. Okay, so you have less than 0. Okay, all these values and all these values. Okay, for this part and this part. So you have x less than 0 or x greater than 3. This is 3. Okay, so let's move on. Okay, we still on question 6. Okay, now question 6.5. Okay, determine the maximum vertical distance between h and g if h of x is equal to minus f of x for x in this interval. So g of x is equal to this from question 6.3. G of x is equal to this. This is g. Now h of x is equal to minus f of x. When you multiply f of x by negative 1, you are going to have h of x. So this is equal to negative x squared plus 2x plus 3. Okay, so you have to understand, if you multiply the equation of a graph by negative 1, you are going to reflect the graph about the x-axis. Okay, when you multiply y or the equation of a graph, you are going to have the original graph reflected about the x-axis. So you are going to have this. This is h and g. You have vertical distance between h and g. Can you see? Okay, this is not a maximum because this is short. You have to find the maximum. To find the maximum vertical distance, you have to find the equation first, the equation of the vertical distance. You are going to have the equation of the top graph, which is h, minus the equation of the bottom graph, which is g. So for the top, you have h, the distance is equal top graph. Okay, h, top graph minus bottom graph. This is the bottom graph, g. So minus x plus 3. Remember, the negative is going to change the signs. You are going to have minus x plus 3 because of the negative. So d is equal to, you have minus x squared, you have 2x minus x, okay, plus x, 3 plus 3 plus 6. So this is the equation that you can use to find the maximum vertical distance between H and G. Okay, so you need to find the x value which is going to give you the maximum vertical distance. So find the x coordinate that will give the maximum vertical distance. So you can use this method. From the quadratic formula, you can pull this out. Okay, this is a quadratic equation. You can pull out this from a quadratic formula. So this is equal to, you have a is equal to minus 1, b is equal to 1, c is equal to 6. Okay, minus b is 1 over 2a. 2 times a is equal to minus 1. This is equal to 1 over 2. You can also use calculus. You are going to take the derivative of this. So you have minus 2x plus 1. Now you are going to equate the derivative to 0 and you solve for x. So you have minus 2x is equal to minus 1, x is equal to 1 over 2. Can you see? Find the maximum vertical distance. You have, this is equal to, x is equal to 1 over 2 squared plus x. This is x plus 6. You are going to have 25 over 4, which is 6.25. Okay, so x is equal to 0.5, somewhere there. Okay, so you are going to have the maximum vertical distance somewhere there. Okay, now 6.6 given k of x is equal to g of x minus n. Determine n if k is a tangent to f. So k of x is equal to g of x. This is g of x minus n. Okay, so this is k of x. Determine n. Okay, determine n if k is a tangent to f. This is f. Okay, this is f. We have the equation of f. F prime of x is equal to the gradient of the tangent which is touching the graph of f. So f prime is equal to m. M is the gradient of the tangent. So the gradient of the tangent is equal to 1. You have an invisible 1 in front of x. This is in the form y is equal to mx plus c. M is equal to 1. C is equal to negative 3 minus n. Okay, let me show you. This is c. Okay, this is c. M is equal to 1. Okay, m is equal to 1. Let's find f prime of x. F prime of x is equal to 2x minus 2. So this is equal to 1. Let's find the x coordinate of the point of contact. The x coordinate of the point of contact. Let's find, you have 1, plus 2, which is 3, x is equal to 3 over 2, okay? This is the x coordinate of the point of contact between K and F. So if we have the x coordinate and the y coordinate, we can use that point to find n. So we can find f of 3 over 2, which is equal to minus 3. You are going to have minus 15 over 4. So this is the y coordinate of the point of contact between K and F. This is y. K of x is y equal to x. This is x minus 3 minus n. Now you can find n. N is equal to, you are going to have 9 over 4. In decimal, this is 2.25. So we have n, okay? Now question 7, okay? 7.1. 6 years ago, Tabo bought a phone for 13,000 rand. The value of the phone depreciated annually according to the reducing balance method. The value of the phone is now 8,337.75 cents. Calculate the annual rate of depreciation. 3 marks. So for reducing balance method, you have to think of the following formula, okay? Because you have reducing, okay? Reducing, you are going to have minus, okay? For straight line depreciation, you are going to have this formula. So 7.1, calculate the annual rate of depreciation. 3 marks. You have this formula. You have A, which is the final amount, and you have B, the initial amount. So N is equal to 6 years. Okay, let's plug everything that we have into the formula. A is equal to this. This is equal to, you have this in bracket 1 minus I. You close your bracket to the power of 6. We have to solve for I. So we are going to divide by 13,000 on both sides. On this side, you have this, which is equal to this. Now you have to get rid of the exponent. You are going to take the 6th root of this. This is equal to the 6th root of this. Now let's find this. Or we can leave this like this. Okay, let's leave this like this. Instead of rounding off, we are going to leave it like this. So this is equal to, you have 1 minus I. So you have minus I. You transpose to the left. You have I is equal to 1 minus this. Okay, 1 minus this on the right side. 1 minus this. Okay, you are going to have 0.07135. 0.07135. Okay, so to find in percentage, you are going to multiply by 100. Okay, by 100 you have 7.14%. Now question 7.2, Eric and Tandy need to save 80,000 rand each to go on a holiday at the end of December 2027. Tandy decided that she will start saving at the end of January 2025. She will make 36 monthly deposit into a savings account that pays interest at 8.6% per annum, compounded monthly. The deposit will be made at the end of each month. Now, Eric calculates that if he makes 48 deposits of 1,402.31 cents starting at the end January 2024, he will have enough money to go on holiday. He will make his deposit into a savings account at the end of each month. The savings account pays interest at 8.6% per annum compounded monthly. Calculate the difference between the total amount that Eric and Tandy will deposit into their respective savings account over the given period. So, amount deposited by Eric, you have this amount times 48. This is equal to okay, 67,310.88 cents. Okay, and now for Tandy, we don't have the calculation for Tandy, so this is the target. Okay, this is the target. This is what each Eric and Tandy want to have in the future. Okay, so to find the monthly deposit for Tandy, we are going to use the future value formula. We are going to use this formula. So we have F is equal to, you have X times, in bracket, you have this. Okay, 1 plus I. This is I. You divide by 100 and then by 12 because you have compounded monthly. To the power of n is 36. Okay, minus 1 over, you have I, compounded monthly. Okay, so we need X. Okay, to find X, you are going to have this to the top and this to the bottom. Okay, so you have X is equal to this to the top, so you are going to have 80,000 times this. Okay, this to the top over this to the bottom. Okay, X is equal to Okay, so this is X for Tandy. Okay, now the amount deposited will be this times 36, which is equal to okay. So can you see for Tandy you have this, for Eric you have this, which is not 80,000 rand. So Eric and Tandy will have to carry on so that they can have 80,000 rand. Okay, but the question says calculate over the given period. Okay, so we have to calculate the difference. You are going to take the biggest minus the smallest. Okay, the difference is equal to this minus what you have there. You are going to have this. So this is the difference. Okay, now question 7.3. Okay, question 7.3. Lesibana was granted a loan of 225,000 rand. The rate of interest for the loan is 9% per annum, compounded monthly. Lesibana will make monthly payment of 5,500 rand starting exactly 4 months after the loan was granted. How many payments will Lesibana make to settle the loan? So let's have a timeline. So our timeline from this moment the loan is granted. Okay, this is the value of the loan. Normally you have to start paying for the loan after 1 month and so on. Okay, normally you have to start paying for the loan after 1 month the loan was granted. Okay, normally. So all the way to the end, you are told, when you read, you are told Lesibana will make monthly payment of 5,500 starting exactly 4 months after the loan was granted, instead of starting 1 month after the loan was granted. You have after 4 months. Okay, so you are there. First payment of 5,500. So the value of the loan is going to increase because you have missed payment. Okay, you have 1, 2, 3 missed payments. So the value of the loan will increase. Let's find the new value. We are going to use this formula. So initially you have this, the rate is 0.09 over 12. N is equal to 3 months. Okay, missed payment. So this is equal to okay. Now you have the new value of the loan. this one. Okay, so because of missed payment, the loan is going to increase. Now you have the new value of the loan. So for the loan, you are going to use this formula, present value formula for the loan. So we are going to use this formula. This is P equal to, you plug everything that you have, you are going to have this. Okay, we need to find N. So we need to have this on its own because we need N. So you are going to have this at the top and this at the bottom. So you have this alone is equal to this times this. Okay, and then over this. Okay, so you have this at the top and this at the bottom. Now you have this alone. You can have this to the right. You are going to have this to the right. Let me show you. This. Okay, this to the right. And you are going to have this to the left. Okay, so this to the right, you have this. You can write on the left side if you want. Now on the left side, you have 1. You bring this to the left side, minus, okay, 1 minus this. So now let's use our calculator. Okay, you have this to the power of negative n equal to, on the right side, you have this okay. Now you need n. You are going to introduce log. Okay, you are going to introduce log. Okay, you introduce log. Now you are going to drop your exponent. Okay, negative n times this. Okay, you drop your exponent down times this. This is equal to this. Okay, so this is according to the properties of log. Okay, now n is equal to, you have this divide by negative log of this. Okay, negative log of this. This is equal to, you can use your calculator. you have to round up. So you are going to have 51 payments. Okay, 51 payments. Question 8. 8.1. Determine f prime of x from first principles if f of x is equal to 1 over x. 5 marks. Okay. 8.1. So they can say determine from first principles or determine using the definition. You are going to use this formula. Okay, this formula is given on the information sheet. So you have f prime of x is equal to the limit as h approaches 0. Okay, so you have f of x plus h. You are going to plug x plus h wherever you have x. So you are going to have 1 over x plus h. Okay, you plug x plus h wherever you have x. You have this minus. Now you have f of x. You are going to plug x wherever you have x. Okay, so you are going to have 1 over x. This is over h. Okay, we carry on. F prime of x is equal to the limit as h approaches 0. Now you have this in the numerator. Okay, you have this in the numerator. You are going to take your common denominator for this. Okay, you have x times x plus h. This is the common denominator for what you have there. So now you have how many times x plus h goes into this denominator. Okay, how many times? Once. You are going to have x times 1, you have x minus. Now how many times x goes into this denominator? You have x only once. You are going to be left with x plus h. Okay, x plus h times 1, you have x plus h. Okay, remember, over h. We carry on. F prime of x is equal to the limit as h approaches 0. You have x minus x. Okay, minus h. Okay, over x squared. Okay, plus xh over h. Okay, you have x minus x. This is 0. You can get rid of the h in the denominator. You can do this. Let me show you. You can multiply by 1 over h in the denominator so that you can cancel. Okay, what you do in the denominator, you also do it in the numerator. Okay, so you have f prime of x is equal to the limit as h approaches 0. You have minus h. Okay, this is 0. So you have minus h over x squared plus xh. Okay, you have over 1. Okay, this is 1 times 1 over h. So f prime of x is equal to the limit as h approaches 0. You have minus 1 times 1, which is minus 1. Okay, minus 1 times 1. Okay, you cancel. Minus 1 times 1, which is minus 1, over x squared plus xh. Okay, substitute 0 in the place of h. So f prime of x is equal to whenever you substitute 0 for h, you are going to drop this notation. So now you have minus 1 over x squared plus 0. This is going to be 0. Okay, x times 0, which is 0. So this is what you are going to have. Okay, question 8.2. Determine, we have 8.2.1. Determine the derivative of this, okay, of this with respect to x. Let's rewrite this so that we can find the derivative. So you have 4x to the power of 6. You're going to write it to the power of 1 over 2. Square root means you raise everything to the power of 1 over 2. Okay, you have 4x to the power of 6. This. Now, you're going to change your square root like this. Okay, to the power of 1 over 2. Plus, you have square root of 2. You can leave this. This is a number. We don't want to write a decimal. You are going to have a large decimal. You can leave square root of 2 like this times x squared. Okay, you close the bracket. So this is equal to the derivative with respect to x. You have 4 to the power of 1 over 2. Okay, 4 to the power of 1 over 2. You're going to have 2. Okay, now x to the power of 6, and then to the power of 1 over 2. You have 6 times 1 over 2, which is 3. So you have x to the power of 3. Okay, x to the power of 3 plus you have what you have there. So now, whenever you start taking the derivative, you're going to drop this. So you're going to have 3 times 2, which is 6, x to the power of 2. Okay, you subtract 1 from the exponent, plus now you have your exponent is 2 times your coefficient. Your coefficient is square root of 2. You're going to have this. Okay, x to the power of 1. You subtract 1 from the exponent. So this is your final answer. Okay, now question 8.2.2. Determine g prime of x if g of x is equal to this. Okay, 3 marks. You can rearrange what you are given before you can determine g prime of x. So g of x is equal to, you can divide every term in the numerator by x squared like this. 3x to the power of 4 over x squared minus 4x squared over x squared. Okay, plus 6 over x squared. Okay, you divide every term in the numerator by x squared. Okay, you rearrange what you are given. So this is equal to, you have 3x squared minus, you cancel, you have 4 plus 6. You can bring this to the numerator. You are going to have x to the power of negative 2. Let's find g prime of x. This is equal to 2 times 3, 6, x to the power of 1. Okay, you subtract 1 from the exponent, minus 0. This is 0. Okay, the derivative of a constant is 0. We carry on, minus 2 times 6. This is minus 12. X to the power of minus 3. Okay, you subtract 1 from the exponent. You have x to the power of minus 3. So this is g prime of x. Now, question 8.3, the equation of the tangent to f of x. Okay, you are given f of x. So the equation of the tangent to f of x at x is equal to 1 is given by y is equal to 9x minus 9. Determine the values of b and c for max. Okay, so this is the equation of the tangent, and this is the equation of the graph, which is a parabola. So a tangent is a line. It is in the form y is equal to mx plus c. This tangent is touching this graph, which is a parabola. Okay, this parabola at x is equal to 1. So this is the x coordinate of the point of contact between this parabola and the tangent. The question is to determine b and c. B and c. So whenever you have a tangent touching a graph, you have to know that f prime of x is equal to the gradient of that tangent. Okay, in this example, it's 9. Okay, this is a line in the form y is equal to mx plus c. Okay, m is equal to 9, c is equal to minus 9. Let's find f prime of x. So f prime of x, you are going to have 2 times 3, you have 6, x to the power of 1. Okay, you subtract 1 from the exponent. Okay, 6x, and then plus b, and then plus 0. This is a constant. So this is f prime of x. This is equal to 9. You have to know that f prime of 1 is equal to 9. Okay, because this is the x coordinate of the point of contact. It can be found through this method. So f prime of 1 is equal to 9. Okay, so you are going to plug 1 in there. Okay, this is equal to 9. B is equal to 9 minus 6, which is 3. Okay, you have B. So we have the x coordinate of the point of contact. Let's find the y coordinate of the point of contact. Okay, find the coordinate of the point of contact. You can use the equation of the tangent to find y. So x is equal to 1. Now y is equal to, you plug x. Okay, you have 9 minus 9, which is 0. So this is the point of contact between f of x and y. Okay, now you can use this point in f of x to find c. So use the point of contact to find c. Okay, you have f of x is equal to this. You have x and y. This is y. It's 0. This is equal to 3 times x squared. X is 1 plus b. B is equal to 3 times x. X is 1 plus c. C is equal to negative 6. Okay, negative 6. So we have b and c. Okay, question 9. The graph of f of x is equal to ax cubed plus bx squared plus cx minus 5 is drawn below. Point E and G are the x-intercepts of f. okay, E and G are the x-intercept of f. Now, 9.1 show that A is equal to 1, B is equal to -3, and C is equal to -9. 3 marks. Okay, so 9.1. From this equation, you have to notice that -5 is the y-intercept of f of x. Okay, -5 is the y-intercept of f of x. Okay, so you have the y-intercept at -5. Whenever you are given x-intercept, okay, when you are given x-intercept, you can choose this form. This form is known as the factored form. So at E, you have a turning point and an x-intercept. Okay, a turning point and an x-intercept. So you have two equal roots. So you have -1, okay, and -1 again, okay, and you have 5. They are all your x-intercept, okay. So you are going to substitute into f of x. Let's substitute. You have f of x is equal to A, you have x minus -1, okay, -1, you are going to have +1. You have x minus -1, you are going to have x +1, okay. You substitute -1 in there, you have this, and -1 again in there, you have this, and now you substitute 5 in there, you have -5. Okay, you have another point on the graph, which is the y-intercept. Okay, from the equation you can see this is the y-intercept. You can use this point to find A. So f of x, this graph got the y-axis at -5. Okay, at -5. So you have this point. You are going to substitute into f of x. Okay, remember, at the y-intercept, x is equal to 0. At the y-intercept, x is equal to 0. So this is x, this is y. F of x is y. Is equal to A. Now x is 0. You are going to substitute 0 wherever you have x. Okay. Okay. So now you have -5 is equal to, you have 1 times 1, which is 1, times -5, which is -5. So you have A times -5. Now A is equal to 1. You divide by -5 on both sides so that you can find A. Okay, now substitute A into this equation so that you can find this form of the equation. Okay, so f of x is equal to this. You have A is equal to 1. You still have this. F of x is equal to 1 times this. You're still going to have this. So you have x squared, x times 1, x, 1 times x, x, okay, x plus x, you have 2x. 1 times 1, you have 1 times this, okay, f of x is equal to, you are going to multiply your bracket and you add your like terms. You are going to have this. Okay, this is what you are going to have. Now you can see a is equal to 1, b is equal to -3, c is equal to -9, and d is equal to -5. Okay, so b is equal to -3 and c is equal to -9. Okay, we are done with 9.1. Now 9.2, calculate the value of x for which f has a local minimum value for max. So the graph of a cubic function has got a local minimum value at the turning point. Okay, you are going to have a local minimum value at the turning point. At this turning point, you are going to have a local maximum value. The question is to find the value of x for which f has a local minimum value. You need to find the x value for which f has got a local minimum value. You need to find the x value on the x-axis. So at the turning point, f prime of x is equal to 0. So we need f prime of x. So we have f of x. Now f prime of x is equal to 3x squared minus 6x minus 9. We are going to equate to 0 because at the turning point f prime of x is equal to 0. We are going to equate to 0 so that we can find x. Okay, so you can divide by 3 throughout. You are going to have x squared minus 2x minus 3 equal to, you divide by 3, you have 0. Now factorize. Okay, you have x squared. You are going to have x times x. Now you have 3. From 3 is equal to 1 times 3. Okay, 3 is equal to 1 times 3. And from 1 and 3, you can have the middle term. Okay, 1 minus 3, you have minus 2. So you can use 1 and 3. You're going to have plus, minus. Now you have x is equal to -1 or x is equal to 3. Can you see the -1 for E and 3 for this point, the local minimum? Okay, this point. So f has a local minimum value at x is equal to 3. Okay. Now question 9.3. Use the graph to determine the values of x for which f double prime of x times f of x is greater than 0. Okay, greater than 0 means positive. Okay, so you can have positive only if f double prime of x is negative and f of x is also negative. Okay, because negative times negative, you are going to have positive. Okay, or you can have positive if f double prime of x is positive and f of x is also positive, because positive times positive, you are going to have positive. Okay, greater than 0 is positive. So I'm going to use the colors, the highlighter, to show you where f is positive, where f is negative, and where f is equal to 0. And I'm also going to show you where f double prime is positive, where f double prime is negative, and where f double prime is equal to 0. So I'll be using the blue color for negative, and I'll be using yellow for positive, and I'll be using black for 0. Okay, so let's start with f. So f is negative wherever f is below the x-axis. Okay, below the x-axis, f is negative. Okay, f is negative whenever f is below the x-axis, and f is positive whenever f is above the x-axis. Okay, and f is 0 at the x-intercept. Okay, at the x-intercept, f is 0. Okay, so we are done with f. Now f double prime. F double prime is negative whenever you have concave down. Concave down. Okay, and positive whenever you have concave up. Okay, and f double prime is 0 at the point of inflection. Okay, at the point of inflection, f double prime is 0. The point of inflection is the point where the graph is changing from concave down to concave up. Okay, so now for you to have greater than 0, okay, for you to have positive, you need to have f double prime negative and f negative, or f double prime positive and f positive. So you need this part and this part. You have positive and positive. So you need after 5. Okay, after 5. Can you see? You need after 5, and you have negative and positive. Okay, negative times positive, you are going to have negative. You need positive. Okay, greater than 0 is positive. You also have negative and negative on this part. Okay, negative and negative. So you have at the point of inflection. Okay, that way you are going to have negative times negative, you are going to have positive. You have to exclude -1, because at -1 f is equal to 0. You are going to have 0 times any value, you have 0. So we don't have equal to 0. You are going to exclude. Okay, so let's find the point of inflection. To find the point of inflection, you are going to take f double prime of x, which is 6x minus 6. Okay, 6x minus 6. You are going to equate to 0 and then solve for x. So x is equal to 1. So this is 1. Okay, This is 1. So you need all the values less than 1. Okay, x is not equal to -1, or all the x values greater than 5. Okay, let's move on. Now, question 9.4. Okay, 9.4. For which values of t will the graph of px equal to f of x plus t have two distinct positive roots and one negative root? P of x is equal to f of x plus t. Okay, f of x is equal to this. Remember, the graph of f is cutting the y-axis in -5. Now, you have to determine the values of t for which the graph p is going to have two distinct positive roots and one negative root. Okay? Two distinct positive root and one negative root. Okay? So, they want you to have a graph. They want you to have a graph like this. Okay, you are going to have one negative root and two distinct positive roots. Distinct means different. Okay, different. The only way to have that, you are going to shift the original graph vertically upward. Okay, so let me show you. You need to find your value there first, so that you can see by how much you are going to shift. Okay, you need to find your value there. Remember, from the previous question, it was found that this was equal to 3 when you were calculating 9.2. Okay, the local minimum value is at 3. We need to find the y coordinate of this point so that we can see by how much we are going to shift upward. Okay, so let's find f of 3. F of 3 is equal to, you are going to plug 3 in there. You are going to have minus 32. So you have minus 32. So P of x is equal to f of x. This is f of x plus t. Okay, so you need a new y-intercept. Okay, because if you shift the graph vertically upward, you are going to have a new y-intercept. So this is your y-intercept, the new y-intercept. The question is to find t in such a way you have two distinct positive roots and one negative root. So we need to shift the graph upward. Okay, so if you try to do that, you are going to have one negative root and one positive root, and another root is a 0. We want to have two distinct positive roots, not one positive root and a 0. Okay, a 0. Can you see? A 0. So we have to try to shift again. Now if you shift again, you're going to have a negative root and two distinct positive root. Okay, so you don't have to go below this graph, this one, can you see this graph? Okay, this is your boundary, your lower boundary. You don't have to go below. When you go below, you are not going to have two distinct positive root and one negative root. You have to go above. Do not go below this boundary where negative 5 plus t is equal to 0. Now, up until when will you stop? Okay, I can do this. Can you see? I'll still have one negative root and two distinct positive root. But if I try to do that, I get my turning point at the x-axis. I'm going to have one negative root and two positive roots which are equal. You need two distinct positive roots. So you understand, this is going to be your upper boundary. Okay, you cannot go any more above. So your upper boundary is at that point on the y-axis. You need to find that point. So can you see, from negative 32, now this point is at 0. For the y-intercept from negative 5, you are going to shift by 32 upward. Negative 5 plus 32, you are going to have 27. If you try to have another graph above this boundary, you are not going to have any positive root. So this is your boundary. So this value is in this interval from 0 to 27. Okay, from 0 to 27. So find t. You are going to add 5 throughout so that you can find t. You are going to add 5 throughout. 0 plus 5, you have 5, and you add 5 in the middle, you are going to have minus 5 plus 5, which is 0. So you only have t plus 5, you have 32. Okay, so question 10, you can pause the video and read the question. So 10.1, show that the area of EFGH is given by a of x is equal to this 4 max. This is a rectangle. Okay, the area of a rectangle is equal to FE times EH. FE is equal to B, and EH is equal to, you have from N to P, you have 4 centimeter. Now from N to E, you have x squared, and from H to P, you have x squared. Now to find from E to H, you have 4 minus x squared minus x squared. Again, you are going to have EH. Okay, so EH is equal to 4 minus 2x squared. Okay, so now the area of rectangle EFGH is equal to FE is B times EH. This is EH. We have to find what is B equal to. So you have B. Let me show you. This triangle and this triangle okay, so the two triangles have got a common angle, the angle N, and this side, okay, FE is parallel to MD. So you are going to use proportionality to find B. Okay, this side is equal to 3. Okay, this side you are given, and this side ND is equal to 2. Okay, because from N to P you have 4. Now from N to D you have 2. So using proportionality you have ND over MD is equal to NE over FE. Let me show you. Let's find B. So let's find B. You have ND over MD. This is equal to, okay, ND goes with NE. Okay, ND goes with NE over MD. Okay, MD goes with FE. Okay, FE. Okay, this is proportionality. So you have 2 over 3, which is equal to NE. Okay, NE is equal to x squared over FE. FE is B. So now you can find B. You are going to cross multiply. So you have 2 times B is 2B. This is equal to 3x squared, and B is equal to 3x squared over 2. The area of EFGH is equal to B times what you have in the bracket. This is equal to 6x squared minus 3x to the power of 4. Okay. Question 10.2. Calculate the maximum area of rectangle EFGH. For marks. To find the maximum area, we are going to use calculus. So the area is given by this. Okay, this is the area. We have to take the derivative and equate to 0 and solve for x. The x value will give the maximum area. Let's take a prime of x. This is equal to 12x. Okay, minus 12x to the power of 3. Now we are going to equate to 0. Let's factorize. You have 12x in this term and 12x in this term. So you can take 12x outside of the bracket. You have 1 minus x to the power of 2. Okay, this is equal to 0. You have 12x times you have difference of 2 squares. Okay, you are going to have this. This is equal to 0. Now 12x is equal to 0, and so x is equal to 0. You divide by 12 on both sides. You have x is equal to 0, and you have 1 minus x is equal to 0, and so x is equal to, you have x is equal to 1, and you have 1 plus x is equal to 0, and x is equal to minus 1. Okay, can you see x equal to 0 will not give you the maximum area, because you are going to have 0 minus 0. If you plug x equal to 0, you are going to have 0 minus 0, which is equal to 0. So this cannot give you the maximum area. Okay, x is not equal to 0. We can use x is equal to 1 or x is equal to minus 1. We can plug in there. You are going to have the same answer. Okay, because minus 1 squared is the same as 1 squared, or minus 1 to the power of 4 is the same as 1 to the power of 4. So let's use the positive x value. So we are going to plug in the a of 1 is equal to 6 times 1 to the power of 2 minus 3 times 1 to the power of 4. This is equal to 3 centimeter squared. Okay. Question 11.1. Two events A and B are such that the probability of A is equal to 0.4. The probability of A or B is equal to 0.52. Okay, this is union. Now, you are told A and B are mutually exclusive. Calculate the probability of B. 2 marks. So, this is the formula on the information sheet. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So the probability of A and B is the probability of the intersection of A and B. So for mutually exclusive events, the probability of the intersection is equal to 0. So this formula is going to reduce to this. Okay, we are given the probability of A or B. Okay, 0.52. This is equal to, we are given the probability of A, which is 0.4, plus the probability of B. Okay, so the question is to calculate the probability of B. 2 marks. Okay, so you have the probability of B is equal to 0.12. Now, question 11.2. Okay, 11.2.1. Okay, what is the probability that the learner will buy a sandwich? 1 mark. Okay, so the probability for a sandwich, you are going to take everything inside this circle. Okay, a sandwich S. Okay, a sandwich S. Okay, so the probability is equal to 0.01 plus 0.02 plus 0.04 plus 0.09. Okay, this is equal to, you can use your calculator. okay, 0.16, okay. Now, question 11.2.2. Calculate the probability that the learner will buy at least 2 of the 3 items, 2 marks, okay. So, when they say at least 2, it means you start at 2 and then 3 and 4, okay, going up, okay. If they say at most, for example, at most 4, it means you start at 4, going down, okay, going down, you go down. So, we have to choose 2 items and 3 items because the maximum is 3. So, at least 2, we start at 2, going to 3. The maximum is 3. So, the probability of a learner buying at least 2 items, we have, this is between C and S, okay, chocolate and a sandwich, okay, at least 2 items, and this is at least 2 items, okay, the probability of at least 2 items, chocolate and juice, and this is at least 2, okay, a sandwich and juice, and this is 3, okay, 3 items, chocolate, a sandwich and juice, okay. So we are going to add the probabilities. So you have 0.02, okay, plus 0.03, okay, plus 0.04, okay, plus 0.01, you're going to have 0.1, okay. Now, question 11.2.3. Calculate the probability that the learner would not buy any of the 3 items, okay. So, we are looking at the probability outside of the circles. So, the total of this, okay, the total is 1. So, we have the probability of a learner not buying any item is equal to 1 for the total minus everything that you have in the circles. So, you have 0.01 plus 0.02 plus 0.03, okay. Let me show you. We have used this, and this, okay, plus 0.04, okay, this, and then plus 0.04 again, okay, and then plus 0.09, okay, this, and then 0.20, okay, plus 0.20, okay. So this is equal to, you have 0.57. So outside of the circles, okay. Let's move on. Question 11.3. 11.3.1. In how many different ways can the names of the guitar players be listed, one below the other in the program. 1 mark. Okay. 11.3. Now 11.3.1. Okay. So we have 7 guitar players with different names. Okay. Okay. So I'm going to use the letters B, C, D, E, J, K, L to represent their names. Okay. They've got different names. Okay. 7 guitar players. Okay. 1, 2, 3, 4, 5, 6, 7. So I'm going to use this to put their names. Okay. I've got 7 places. Okay. 1, 2, 3, 4, 5, 6, 7. Okay. I've got 7 places to put their names. Now I have 7 players. We have to put their names one below the other. Okay. So in the first place, I've got 7 options to choose from. I've got 7 choices to choose from. I can put B or C or D or E or J or K or L in the first place. Okay, so I've got 7 options to choose from. Okay, so in the first place, I've got 7 options to choose from. Okay, so for example, I can choose J to be in the first place. Okay, now I'm left with 6 players to put on the second place. I've got 6 options to choose from. Okay, so I can choose D, for example. Okay, D. Now in the third place, I've got 1, 2, 3, 4, 5. 5 options to choose from. Okay, to choose from. I can put C in the third place. Okay, now I've got 4 options to choose from. Okay, 4 options to choose from. I can put B, for example. Okay, I can put B. Now I have 3 options to choose from. 3 choices to choose from. Okay, so I can choose K. Okay, in the 5th place. Now I'm left with 2 options. Okay, 2 choices to choose from. Okay, so I can put L. I have 1 option to choose from. Okay, so you are required to put their names one below the other. Okay, so these are all the options you have. Okay, 7 times 6 times 5 all the way to 1. Okay, so this is equal to, you can use your calculator. Okay, you have 5040. Okay, or you can write this as 7 factorial. This is equal to 5040. You can see 7 factorial. You press shift, you have factorial there. Okay, 7 factorial. Okay, so you have this. Okay, 7 factorial means you have to multiply from 7 all the way to 1. Okay, so you can give your answer like this or like this. Now, question 11.3.2. So, after the performance, the guitar players wait backstage. There is a bench with only room for 4 to sit on. So, the question is, what will be the probability that the 4 guitar players will be sitting in alphabetical order from left to the right. 3 marks. Okay. The probability that the 4 guitar players are seated in alphabetical order. Okay. So this is a bench with only room for 4 to sit on. Okay. Let's find the total outcome first. We have 7 players. Okay. Let's find the total outcome using this bench. So on the first seat, I've got 7 options. I've got 7 choices to choose from. Okay. I can put D on the first seat. Now I've got 6 options to choose from to put on the second seat. Okay, I've got 6 options to choose from. I can put K. Now on the third seat, I've got 5 options to choose from. Okay, 5 options to choose from. I can put J. On the fourth seat, I've got 4 options to choose from. Okay, 4 options to choose from. I can put B. Okay, so we can get the total outcome. So the total outcome is 7 times 6 times 5 times 4. Okay, 7 times 6 times 5 times 4. Okay, you multiply your options for each seat. Okay, this is the total outcome. Now the question is, what will be the probability that the 4 guitar players will be sitting in alphabetical order from left to the right? Okay, so in alphabetical order, you start with the first letter. Okay, B, and then C, D, and E. Okay, this can only happen once. This can only happen once. Okay, so you have 1 in alphabetical order from left to the right. Okay, you can only have this once. So this is equal to 1 over 7 times 6 times 5 times 4. Okay, you have 840. Okay, 1 over 840. Okay. Question 11.3.3. During the performance, the 7 guitar players sit in a line on stage. 4 guitar players are female and 3 are male. In how many different ways can they be seated if the males may not sit next to each other? Okay, so the males may not sit next to each other. So I'm going to use this so that we can separate the males. Okay, so I'm going to put the females in this box so that the males can be separated. Can you see? On the left and right of each female, you have a place to put any male. Okay, so we have 4 females. Okay, 4 females and 3 males. So let's start. In the first place, I've got 4 options to choose from. Okay, 4 options to choose from in the first place. Okay, 4. So I can put this one there. In the second place, I've got 3 options to choose from. Okay, so I can put this there. Okay, in the third place, I've got 2 options to choose from. okay? So times 2, okay? I can put this female there, okay? Now I have one option, okay? Times 1. So this can go there, okay? So now for the males, I have 1, 2, 3, 4, 5. 5 places to put the males, okay? 5 options, okay? So I'm going to start with 5 options, okay? So times 5, I can put this guy there. Now I have 1, 2, 3, 4. 4 places, 4 options times 4. So this guy can go there. Now I have 1, 2, 3. 3 places to put the remaining guy. Okay, 3 options to put the remaining male. Okay, 3 places. So I can put this guy there, or this place, or this place. Okay, so this is equal to, this is 4 factorial, okay, 4 factorial, and then times 5 times 4 times 3, okay, this is equal to 4 factorial times 5 times 4 times 3, okay, you have this, okay, so we are done.